All right, so the second video this week involves solving systems. A system is two or more equations with different variables. For us to solve it, usually the number of equations has to be equal to the number of variables. So one of the first ways they show is by graphing. So if you simply graph using the skills you did in Module 11, graphing the lines, you just have to find the point of intersection. All right, so basically if I graph, let's say y equals 3/4 x minus 1, and I graph y equals negative 2x plus 5. All right, we'll make an integer value, 6. We'll just play around until we get an integer value, 7, 8, 9, 10. That looks right. Okay, so we're looking at these two. So you would graph it. The 3/4 x minus 1 would start at negative 1, okay, because that is your y-intercept. And then you would go up 3 and over 4. So 1, 2, 3, 1, 2, 3, 4. All right, and then you would connect them with a line and keep going and keep going. All right. All right, so I'm just going to plot it 2, 1/2. There's the next point. And then you would plot them. All right, so you would plot those and then go. You would do the same thing then with negative 2x plus 10. All right, which you're going to start up here at 10, and then the slope is negative 2. So you would go down 2 and over 1, and then connect those. All right, most importantly, you would see a point of intersection. That point of intersection is the solution of a system. So you have to graph the lines and then find that point using the graphing tool provided for you in the assignment. All right, so 4, 2. If I plug 4 back in for x to here, all right, the 4's cancel out. I'd have 3. 3 minus 1 is 2. If I plug it in here, negative 2 times 4 is negative 8. Negative 8 plus 10 is 2. So it's the values of x and y, all right, that solve the equation simultaneously. Now, the problem with that, okay, if we come back here, the problem with that, all right, is if, let's say I change this to 9. All right, and now my solution is this value, and it's going to be really hard to do that in a graph with precision. So they developed algebraic methods in order to solve. All right, so we got a couple things at our disposal. One of them is called substitution. With the word substitution, we basically replace the variable with the value. So if I have 5x minus y equals 12, and then y equals 1/2 x plus 3. You literally take, okay, whatever y is equivalent to. All right. So you literally take whatever y is equivalent to and you substitute it in the other equation. It's got to be the other equation. If you put in the same equation, you're going to end up working backwards. You're not going to help yourself. So it's always the other equation. So I take the 5x minus y equals 12. All right. All right. And all I'm going to do is replace the y with whatever it's equivalent to. 1/2 x plus 3. All right, the reason I do that is I now have one variable, and that's what I want. All right, now if you don't like the 1/2 right away from our equation solving skills, we can multiply everything by 2 right away, but remember to do it to everything. So the 5x would become 10x, the 1/2 x would become x, the 3 would become 6, and then the 12 would be 24. All right, so if you're a fraction phobe like some people are, you want to get rid of it, you multiply everything by the denominator. 10x minus x is 9x. 9x plus 6 equals 24. All right, you subtract the 6. 9x equals 18. X equals 2. All right, and then what you basically do is you've done 90% of the work, but you only have half the solution. Why? Because you have the value of x. Well, that's when we go back to our original equation up here. Okay, that's when we go back to our original equation up here, and we replace the value of x with it. All right, so we're looking at y equals 1/2, and that's why it's called substitution. You replace it with the value you get. 1/2 of 2 is 1. 1 plus 3 is 4. So my answer, or quote unquote solution, would be 2, 4. All right, so that would be substitution. Now elimination is the second method, and what we want to do is we want to get variables that are opposites of each other, because that way when we add straight down, they cancel out. So let's add 2x minus y equals negative 5. Let's play with some negative numbers for a second. And then x plus y equals 10. All right. You will notice we have a negative y here and a positive y there. So you literally put a line underneath and add straight down as long as the variables line up. All right? So the variables have to line up. So the x's line up here, the y's line up there, and then we have the constants. So when we add straight down, 2x plus x will give me 3x. The negative y plus y cancels out. Negative 5 plus 10 is 5. All right, then we would divide by 3, and x equals, all right, 5 over 3. All right, make sure you follow directions that they give you and what format they want it. If they want it as a simplified fraction or a mixed number or whatever, but 5/3 is the value. We then do the same thing we did with substitution, which is plug it back in. I can plug it into either one of my equations. All right, I can plug it into either one of my equations. So just because it's easier, all right, I'm going to plug it into the bottom one. All right, I'm going to plug it into this one right here. All right, which means, all right, when I do, okay, okay. Okay. Technology at its finest. Sorry about this. All right, I'm going to come over here, create a text box. That should be able to let me put it in. So I'm going to take that second equation, which is x plus y equals 10, and I'm going to replace the x with 5/3. All right, so that's going to be 5/3 plus y equals 10, and I'm going to solve for y by subtracting 5/3. I would turn 10 into 30/3, subtract the 5/3, and y equals 25 over 3. All right. So that's how substitution and elimination works. What we'll try to do is create a video when you have to do different things and making choices. But that hopefully gets you set up on what the idea is behind different methods of solving. I hope it helped. Best of luck to you. Talk to you soon. Bye.